Okay, Assalamualaikum warahmatullahi wabarakatuh. Today we are going to discuss acid-base properties of salts. Alright, first of all, let's introduce what is salts. Okay, salts are produced from the neutralization reaction between acid and base. You may have learned this before. This is just as revision. Example is of a neutralization is if you have a sodium hydroxide, which is a base, react with hydrochloric acid, which is an acid, it will produce salt, sodium chloride, and water, H2O. Okay, salts are also electrolytes. Okay, this is also you have learned earlier. We just want to revise it back. Electrolyte means it is made up of oppositely charged ion. Okay, so when dissolved in water, they will dissociate into this oppositely charged ion. When the salt is dissolved in water, the oppositely charged ion will be free moving. Okay, for example, here we have calcium chloride. So what happens when we dissolve calcium chloride in water, it will becomes aqueous solution. So inside the aqueous solution will be free moving calcium ion. So calcium ion is a positively charged ion, which we also call as cation. And there is also presence of chloride ion, Cl minus. Cl minus is a negatively charged ion, which we also know as an ion. Okay. Since ions can also exhibit acidic and basic properties, therefore salts can also be acidic or basic depending on the behavior of its cations and anions. Okay, remember we have learned earlier about definition of acid and bases by Bronsted-Lowry. So if you still remember, these have expanded the category of acid and base into so many substance. This includes ions. So ions can also becomes acidic or basic. And since salts are made up of ions, therefore salts also can be acidic or basic, okay, depending on the behavior of its cation and anions. The reaction between cations and anions in water is called hydrolysis. We will come back to hydrolysis later because hydrolysis is important in categorizing whether the salt is acidic or basic. So basically, salt hydrolysis will generate H plus or OH minus and therefore can affect the pH of the solution. So the cation and anions in the salt, when dissolved in water, they can also react with the water and they will generate either H plus or OH minus. When they generate either H plus or OH minus ni, they will increase the concentration of H plus or OH minus, therefore it will affect the pH. Alright, so this is the revision of Bronsted-Lowry definition of acid and base. Okay, so basically acid is a proton acceptor, which means that acid can accept H plus, and when it accepts H plus, it will form conjugate base. Okay, while base is a proton donor, that means base will donate its H plus, and after the donation of the H plus, it will becomes conjugate acid. Alright, so what happens when we have a reversible reaction between acid and conjugate base? Acid, when accepting H plus, will become conjugate base, and at the same time conjugate base can also change to acid. Okay, but what happens if the production of conjugate base from acid is relatively easy? That means acid can easily change to conjugate base. Say like 90% of acid can dissociate and become conjugate base. That means the reverse reaction will be relatively hard. Okay, so if acid can change 90% to conjugate base, that means only 10% of conjugate base can becomes acid back. Okay, so this makes acid as strong acid, while the conjugate base is a weak base. Okay, and the same goes vice versa. What happen if the acid is very weak? So the acid will be difficult to change to conjugate base. The percent ionization will be very low, which means that from acid to become conjugate base, it will be very hard. Maybe only 10% of the acid can be changed to conjugate base. That means the reverse reaction, which is the reaction to change conjugate base to acid, will be relatively easy, which is 90%. That means conjugate base can easily change to acid, but acid is very hard to produce conjugate base. So this process will make acid as weak acid, and conjugate base is relatively strong base. So this is basically the concept. We are going to use this concept later when explaining the acidity and basicity of the salt. Alright, so come back to hydrolysis of ions in water. Okay, what happens when these ions react with water? Cation will donate proton to water and producing hydronium ion. This is hydronium ion, or we call it hydroxonium ion. Or some book they will just simplify by putting H plus ion. So when cation react with water, they will donate the electron and becomes NH3, and the water will become H3O plus. So this will make the concentration of H3O plus in the solution increase. Therefore, it will lower the pH and make the solution acidic. Anion will be the opposite. They will receive the proton from water and produce hydroxide ion. So this is the hydroxide ion. So let's say we have Cl minus as negatively charged ion, or the anion. It will receive H plus from the water, becomes HCl, and the H2O will becomes OH minus. So OH minus will increase the concentration of OH minus in the solution and make the solution more basic, thus increasing the pH. So this is also the concept that we are going to use later. Okay, so we are going to apply all the concept that we have learned earlier when explaining the type of salt. Okay, let's start with acidic salt. Okay, let's say we have NH4Cl. So what we are going to do first is to find the parent, which is to identify the acid and base that produce the given salt. Okay, we are going to identify what type of acid and base that makes NH4Cl. Okay, as we know, salt is produced from neutralization. Neutralization requires acid and base. So we are going to find the parent. We are going to find the acid and base that is responsible to produce NH4Cl. Okay, so how do we do that? Okay, we know earlier that acid and base will give us salt and water, and we know that acid consists of H plus, base consists of OH minus. So acid, since H plus is a positively charged ion, it must combine with a negatively charged ion. Okay, let's say it is an A minus. While base, since it has OH minus, which is negatively charged ion, must be combined with a positively charged ion. Let's say B plus. So your H plus and OH minus will combine and becomes H2O. That means the salt will come from A minus and B plus, becomes BA or AB. Okay, so B plus or the cations from the salt is contributed by the base, and A minus or anions from the salt will be contributed by the acids. So this is how we are going to trace the parent. Okay, we are going to trace the acid and base that is producing the salt. Okay, we know that NH4 plus is NH4Cl is made up of NH4 plus, that is the cation, and Cl minus. Okay, that is the anion. Okay, NH4 plus. Okay, since it is a cation, it should comes from our base, so it should comes from NH4OH, while Cl minus, our anion, should comes from our acid, therefore it comes from HCl. Okay, so NH4OH is a weak base. Okay, we have learned this earlier to identify whether the acid or base is strong or weak. So NH4 plus is ammonia family, have nitrogen and hydrogen, therefore we consider as weak base, while HCl is a hydrohalic acid, so it is a strong acid. Okay, and what happened? Since we know that our base study, okay, our base will produce NH4 plus and OH minus, so NH4 plus is our conjugate acid. Okay, and since NH4 plus OH is weak base, the conjugate acid NH4 plus is strong conjugate acid. Okay, we have learned this earlier from the earlier slides, that weak base will give strong conjugate acid. If it is a strong base, it will give weak conjugate acid. So our acid pula, HCl, okay, will produce Cl minus and H plus, and since HCl is an acid, Cl minus will be its conjugate base, and since HCl is strong acid, therefore Cl minus will be weak conjugate base. And since NH4 plus is a strong conjugate base, therefore they can hydrolyze in water. Okay, they hydrolyze in water like we have discussed earlier. The NH4 plus will donate its H plus and becomes NH3, and the H2O will receive H plus and becomes H3O plus. So the hydrolysis produce hydronium ion, therefore making the solution acidic. That's why our NH4 plus Cl is an acidic solution. Okay, what about Cl minus? Cl minus, however, is a weak conjugate base, therefore do not undergo appreciable hydrolysis, so it does not contribute to the acidity or basicity of the solution. Okay, using the same concept, let's explain about basic salt by using the second example. Okay, here we have sodium ethanoate. Okay, again we are going to find the parent. Okay, Na plus NaCH3COO minus is made up of Na plus and CH3COO minus. Na plus is cation, so it comes from base, therefore the base is NaOH. CH3COO minus is an ion, therefore it comes from acid, so the acid is CH3COOH. NaOH is strong base, while CH3COOH is weak acid. Okay, NaOH is strong base, which means that NaOH is a base, which means that Na plus is its conjugate acid, and since NaOH is strong base, then Na plus will be weak conjugate acid. Okay, similarly, our CH3COOH is an acid. It will produce CH3COO minus as its conjugate base, and since CH3COOH is a weak acid, therefore CH3COO minus is a strong conjugate base. And since Na plus is a weak conjugate acid, it do not undergo appreciable hydrolysis like what happened to Cl minus just now, and it does not affect the pH of the solution. Okay, however, CH3COO minus is a strong conjugate base, therefore they can hydrolyze in water. So what happens? CH3COO minus will hydrolyze in water, receive the H plus and become CH3COOH, and H2O will become OH minus. And since the hydrolysis produce hydroxide ion, therefore the solution becomes basic. So that's why our sodium ethanoate is a basic salt. And last one, we use the same concept to explain neutral salt. Okay, using NaCl, sodium chloride. So again, we are going to find the parent. Okay, NaCl is made up of Na plus and Cl minus. Again, Na plus is positively charged ion, so it comes from base. So the base should be NaOH. Cl minus is the anion, comes from acid, so the acid should be HCl. Both sodium hydroxide and HCl are strong base and strong acid respectively. So sodium hydroxide as a base produce Na plus as its conjugate acid, and since sodium hydroxide is strong base, Na plus is weak conjugate acid. And similarly, HCl is an acid producing Cl minus as its conjugate base, and since HCl is strong acid, Cl minus is also a weak conjugate base. And since both Na plus and Cl minus are weak conjugate acid and conjugate base, therefore both do not undergo appreciable hydrolysis. So both did not contribute to the acidity or basicity of the solution. Therefore, the salt is neutral. Okay, so you can try this on your own using these three salt. Okay, and try to use the explanation that I have shown earlier. That's all.